Hello everyone, welcome back to our channel. So in this video, we will dive deep into the world of AWS Lambda functions and serverless computing. So get ready to unlock the power of serverless architecture as we explore how AWS Lambda simplifies the deployment of code without the hassle of managing servers. So let's start the video. So the title of our video is AWS Lambda Functions, a beginner's guide. So let's start. First, we will see what is serverless computing. So, a serverless computing is a cloud computing model where cloud providers like AWS, Azure, or Google Cloud manage the infrastructure, allowing developers to focus solely on writing and deploying code without worrying about provisioning or managing servers. So, now we will differentiate between server and serverless computing. So, first, we'll see the aspects infrastructure. So, server computing requires provisioning and management of servers, but serverless computing abstracts server management and there is no need to provision servers. Resource management. In server computing, manually configure resources for anticipated load, but serverless computing, it is automated scaling based on demand. Cost and structure. Ongoing costs for provision servers, whereas serverless computing, in that we have to pay as you go model, pay only for resource used. So scalability. Limited scalability. Scaling requires effort in server computing, but in serverless computing, it is automatic scaling based on workload. Maintenance. In server computing, the maintenance is manual maintenance and updates required, whereas in serverless computing, the provider manages the infrastructure updates. Execution model. So in server computing, it is a continuous execution model, whereas in serverless computing, it is event-driven execution model. Responsibility. So in server computing, it has greater responsibility for server management, whereas in serverless computing, it is reduced operational responsibility and it focuses on code. So now we will see what are the benefits of serverless computing. So why are we using AWS Lambda, and why should we use serverless computing? Why should the developer need serverless computing? We'll see the benefits of it. First is scalability. So serverless platforms automatically scale to accommodate varying workloads. They handle the load and resources, ensuring optimal performance without manual intervention. Second is cost effectiveness. You only pay for the resources used while your code is running, often measured in milliseconds. There is no need to pay for idle time or provision capacity. Third is reduced operational overhead. Since infrastructure management is handled by the provider, developers can focus more on writing code and building application rather than managing servers, scaling or maintenance. Faster time to market. So serverless allows rapid deployment of code, changes, updates and new features, enabling quicker iteration and deployment cycles. Event-driven architecture. Serverless architectures are inherently event-driven, allowing functions to be triggered by various events, such as HTTP requests, database changes, file uploads from connector services, enabling powerful integrations. So now first we'll see what is the definition of AWS Lambda. So AWS Lambda is a serverless compute service provided by Amazon Web Service that enables users to run code without provisioning or managing servers. It allows developers to upload their code and Lambda automatically handles the infrastructure required to run that code. I hope by reading this definition it is very clear to you what AWS Lambda is. So we'll move on. Now we'll see what are the benefits of using AWS Lambda. As a developer, me and you, why should we use AWS Lambda in our day-to-day life? So first is serverless computing. Developers can focus solely on writing code without managing servers. AWS Lambda abstracts the underlying infrastructure, enabling a serverless computing environment. Cost effective. Lambda follows a pay-as-you-go pricing model. Users are charged only for the compute time consumed during code execution with no charges for idle time. So this cost effectiveness makes it ideal for sporadic or low traffic applications. Third is automatic scaling. Lambda scales automatically in response to the number of incoming requests. It manages the required resources to execute code, ensuring scalability without manual intervention. Event-driven architecture. So Lambda functions can be triggered by various events such as HTTP requests, changes in data storage like S3, database notifications, DynamoDB, or custom events using AWS SDKs. So now we will see which are the languages which are supported in AWS Lambda. First one is Node.js, which is JavaScript based runtime environment for server-side applications. Second is Python. It is a high-level programming language known for its simplicity and readability. Third is Java. Java is an object-oriented programming language with a strong ecosystem. Fourth is Ruby. Ruby is dynamic object-oriented scripting language. Fifth one is Golang, compiled language known for its efficiency and simplicity. And the sixth one is .NET Core or SHIAS, cross-platform open source framework for building different types of applications. So now we will see which are those applications which are supported by AWS Lambda or application in which AWS Lambda can be used. First one is web applications. Lambda can handle HTTP requests via API gateway, making it suitable for building serverless backends for web applications. It can manage user authentication, data processing, and other backend functionalities. Second is data processing. It's ideal for processing data in real time or batch jobs, for instance, handling files, uploads, transforming data, or performing ETL, extract, transform, load operations. IoT application. Lambda can process data streams from IoT devices, enabling real-time analysis, data validation, and triggering action based on sensor data. Fourth one is event-driven workflows. It excels in event-driven architectures, reacting to events from various sources like database changes, file uploads, or custom events from other AWS services. Fifth one is automated tasks. Lambda functions can automate routine tasks such as backups, log analysis, and schedule operation without the need for continuous server resources. So next is applications in which AWS Lambda cannot be used. So first is high performance computing. Applications requiring continuous high compute resources might not be best suited for Lambda due to its event-driven stateless nature. Long-running resource-intensive tasks that need sustained high CPU or memory might exceed Lambda's capabilities or cost efficiencies. Second is legacy systems integration. In cases where applications heavily rely on legacy systems or specific infrastructure that cannot be easily abstracted into an event-driven serverless model, integrating with Lambda might pose challenges. Third is predictable workloads. If an application has consistent and predictable workloads, whereas instances can be pre-provisioned to manage the load effective, using traditional server-based approaches might be more cost-effective than Lambda's pay-per-execution model. Fourth one is continuous workloads. For tasks that require continuous uninterrupted execution or over an extended period without any interruption or scaling down, Lambda might not be the most suitable choice as it is designed for event-triggered short-lived execution. So next we will see additional pricing consideration in AWS Lambda. First one is free tier. AWS Lambda offers a free tier which includes a certain number of invocations and compute time per month, allowing users to experiment without incurring any charges. Second is per GB memory allocation. Lambda allows you to specify the amount of memory allocated to your function. Pricing is based on this memory allocation, with higher memory configurations incurring higher cost per millisecond. Third is no charges for idle time. So there are no charges when your code is not running. You only pay for the compute time used during execution, which is very useful. Fourth one is data transfer costs. Data transfer costs might apply if a Lambda function interacts with other AWS services or external systems. So now we will recall and see the summary of the key points which you have studied recently. First one is AWS Lambda fundamentals. So Lambda is a serverless compute service by AWS, enabling code execution without server management. Its benefits: it offers automating, scaling, event-driven execution, and support multiple programming languages. Third is event-driven architecture. Lambda functions are triggered by events from various AWS services or custom events. Fourth is cost model. Pay-as-you-go pricing based on the number of requests and duration of code execution. Fifth one is automatic scaling. Lambda automatically manages the resources based on incoming requests. Fifth is integration. Seamlessly integrates with other AWS services, reducing operational overhead. So this is the summary which we have covered in our video. So now we will see encouragement for further exploration. Why AWS Lambda should be explored more. We'll cover that. So AWS Lambda unlocks incredible possibilities in building scalable, cost-efficient applications. Experimenting further can first deepen understanding. Try different triggers, languages, and integrations to understand Lambda versatility. Explore integrations. Experiment with combining Lambda with other AWS services for powerful application architectures. Optimize performance. Test and optimize function for cost and performance efficiency. And the last is real-world applications. Apply Lambda in real projects to grasp its impact on actual applications. So thank you everyone for staying in the video and learning from me. If you want to implement AWS Lambda or you have any difficulty, you can connect with us on support@devopscent.com or moinazam7@gmail.com. So thank you so much everyone. See you in the next video.